everyone. Welcome back to our data structure lecture. This is our third unit, stacks and queue, and today's topic is introduction to stack. Introduction of stack. A stack is an abstract data type commonly used in most programming language. It is named stack as it behaves like real world stack. For example, a deck of cards or pile of plates, etc. It is a simple data structure that allows adding and removing elements in a particular order. Stack is an ordered list in which insertion and deletion can be performed only at one end, that is called top. See here in this figure, top is point to the last index of this stack. Stack is a recursive data structure having pointer to its top element. So top is used for the pointing data, means top is point to the last index of this stack. In stack, there are two operations, push and pop. Push means insertion operation, means insert data, and pop means removal operation, means delete data. See here, if we want to push one data, then we insert one data. And if we want to pop one data, means we delete some data. So if we add means push some data, then top is incremented by one index, and if we pop means delete one data, then top is decremented by one index. Stack are called as last in first out, means LIFO. That is, the element which is inserted first in the stack will be deleted last from the stack. So LIFO means last in first out. So see here in this figure, last inserted data is 5. So if we want to delete one data, so automatically that last data is deleted, means here 5 is deleted. That's why we call stack is LIFO, means last in first out approach, because stack contain only one end. That's why if we inserted last element is 5, so 5 is deleted from the stack first. Stack representation in memory using array. Stack represent in two ways. First using array, or second using linked list. An array is defined as the collection of similar type of data items stored at contiguous memory location. An array is used to store an ordered list of elements. Using an array, first representation of stack is one of the easy techniques to manage the data. The array implementation aims to create an array where the first element, usually at the 0 offset, is the bottom. That is, array 0 is the first element pushed onto the stack and the last element popped off. The program must keep track of the size or the length of the stack. So see here in this figure, this is a stack and this is an array. So here we pushed first element is 12. So here in array 12 is present in 0th index. Next insert 8. So here 8 element is present in first index. So here last element is 10. So in array also last element is 10. Next is, for representation stack, we have to declare the following data structure. To represent stack, we use structure. So syntax of structure is struct and structure name. So here stack is structure name. Then we initialize array and variable, that is top. So here initialize Array name is data and size is max. And next variable we declare, that is top, int top. Stack as an ADT. An abstract data type is one where we can store elements and also perform certain operation on those elements. A stack is an abstract data type commonly used in most programming language. Likewise, stack ADT allows all data operation at one aim only. The stack, an abstract data type, is defined as an ordered collection of items where items are added to and removed from the end called the top. Stack contain various operations like push, pop, means insert element and delete element only at one end. Stack provides such facilities. Stack as an abstract data type contains stacked elements such as array list. Stack top and its operations such as initialize, is empty, is full, push, pop and display. Means here we initialize stack, then we check stack is empty or not, then check stack is full or not, then push operation means insert element in stack, then pop operation means delete element from stack, and then display means display stack data. Example of stack using push and pop operation. We see here how to insert and delete some data using push and pop operation, and how to increment and decrement top. So see here, first stack is created and stack is empty. So, so that's why our top is equal to -1. When we insert one element, then our top is point to the 0th location. We insert another element, that is 2. Okay. So now top is incremented by 1 and now top is point to the first index. Next, we, we also push another element, that is 3. Now top is incremented by 1, means top is now 2. Next, we pop one element. In that condition, top is decremented by 1, means now top is equal to 1. Stack operations conditions. First operation is empty. This function is checked if stack is empty or not. Algorithm is, if top is equal to -1, then return true, else return false. So here condition is top is equal to -1. Means if stack is empty, then top is equal to -1. So here if top is equal to -1, if this condition is true, then print stack is empty. And in else part, false means stack is not empty. So next condition is full. This function is check if stack is full or not. Algorithm is, if top is equal to max -1. This condition is true, then return true, else return false. So here, see here in this diagram, max is equal to 4, means size of stack is 4. So start from 0, 1, 2, 3. So when you enter first number, then top is point to the 0th index. Then you push second element, then top is point to the first index, then second and then third. means now top is point to the last index of this stack. So here size of max is 4. 1, 2, 3, 4. Means max is equal to 4 means size of stack is 4. So if top is equal to max minus 1 means 4 minus 1 is 3. So top is equal to 3 or top is already point to 3. This condition is true. Then print stack is full. Otherwise stack is not full. Stack operations conditions. So next condition is stack overflow. Means when stack is contains maximum number of elements, that is stack is full and push operation is called to insert a new element, then stack is said to be in overflow state. See here in this diagram, stack is already full because max is equal to 4 means size of stack is 4 and here already present 4 elements, so stack is full. Whenever stack is full and we called push operation means insert another new element, then stack is overflow. Next condition is stack underflow. When there is no elements in a stack, that is stack is empty and pop operation is called, then stack is said to be in underflow state. See here in this diagram, stack is empty and we called pop operation, then stack is in underflow state. Operation push. Push means insert a new data in this stack. Algorithm for push is step 1. Check for stack full or overflow. Condition is if top is equal to max minus 1, then write stack overflow return. So here now top is point to the first index, so top is 1. Max is 4, so 4 minus 1 is 3. So 1 is equal to 3. This condition is false. So we jump to the step 2, that is top is incremented by 1. So whenever we insert a new element into the stack, then top is incremented by 1. Now in this stack we push 30. So now top is incremented by 1. So top is 1 plus 1 is 2. So now top is point to the second index. So we insert 30 from this index. Step 3 is stack top is equal to item. Means here stack top is 2. So top 2 means we insert 30 in second index. Item means 30. Step 4 is return. So using this algorithm, we insert new data in the stack. So here we insert means push 30 to this stack. Operation pop. Pop means delete data from stack. Algorithm for pop operation is step 1. Check for stack empty or underflow. If top is equal to minus 1, then write stack underflow return. Means if stack is empty and then we want to perform pop operation, then write stack is underflow. So in this diagram, top is equal to minus 1. This condition is false. That's why we jump to the step 2, that is copy data. So here item is equal to stack top. So here top is point to the second index. So stack top means data 30. So here decrement top. So top is equal to top minus 1. So here top is point to the second location. Now top decremented by 1. Then in the second diagram, top is decremented by 1 and point to the first location. That's why here we delete data 30. Step 4 is return. So here we delete one element from the stack. Program for stack. Here we perform operations like push, pop and display. First is header file, that is hash include stdio.h means standard input output header file. Next is standard library header file. Next is hash define max size 5 means here we define size of array is 5. Next we need to define structure. So syntax of structure is struct and structure name. So stack here is structure name and this is we initialize variables. So here int stk means here we initialize array, that is array name is stk and max size is 5. Next initialize int top. Next is type def struct stack st. Here sts is internal pointer variable. So next is function to add an element to stack. So first function is push function. So we define num. Next condition is s dot top is equal to max size minus 1 means here we check if stack is full or not. If this condition is true, then stack is full. Otherwise, we jump to the else part. Else part is pushed element. So here printf enter element to be pushed. Next is scanf %d address of num. Here we enter which value inserted in the stack. Next is s dot top is equal to s dot top plus 1. If we insert a new value in stack, then top is incremented by 1. Inserting value in that particular position means where top is point to that position. So right here s dot stk s dot top means where top is pointing, we insert num in that position. Next is return. Function to delete an element from stack, that is pop. So here we delete element from stack. So first we check if condition, that is s dot top is equal to minus 1. If this condition is true, then print stack is empty. Return s dot top. If this condition is false, then stack is not empty, then we delete one element from that stack. So we jump to the else part. So in else part, num is equal to s dot stk s dot top means here top is point to the last index of that stack means last element of that stack. So here we print that popped element. So here right popped element is %d slash n s dot stk s dot top. So here we print that last indexed number. So next is s dot top is equal to s dot top minus 1 means here if we delete one element then top is decremented by 1. Return num. Next is display function, void display, int I, here initialize I, then if s dot top is equal to minus 1 means here check if stack is empty. If stack is empty, then print stack is empty. Otherwise, we jump to the else part. So in else part, printf status of element in stack. So here we use for loop for printing value present in the stack. So I is equal to s dot top means here we start printing value to from last index. So where top is pointing to the last index. I is greater than equal to 0 and I minus minus means print value from top to the bottom. Means if top is 4 and bottom is 0 means we print value top to 0. That's why we write here I minus minus. Then print value is s dot stki means here using %d we print value from stack. Next is main function, that is int main. Here we define switch case. So uh, we initialize variable, that is ch, for choose operations like push, pop, display. Then we define top is equal to -1. Then printf stack operations. Printf first is push, printf second pop, printf third is display, and fourth is exit. So here we choose these four operations from using switch case. So here while one printf choose operations, first is scanf %d address of ch. So define switch case, switch ch, case 1 push, break, case 2 pop, break, case 3 display, break, case 4 exit, 0. So if we enter case 1, then we add element to the stack. If we choose say 2, then we delete element from the stack. If we choose 3, then display element. And if we choose 4, then program stop. So default case is printf invalid operations, return 0. So next here output is, there are 4 options: push, pop, display and exit. So first we choose operation is 1, means we add element, that is push. So enter element to be pushed. So we write here 45. Next choose operation. So we again choose 1, means we add one element. Enter element to be pushed, that is 52. Next choose operation. So we again choose 1, then enter element to be pushed, that is 63. So we already add in stack 45, 52 and then 63. Now again choose operation, then we write here 3, means 3 means display. So we display stack, that is 63, 52, 45, means first we add 45, that is display in last, then 52 and then 63. Okay, next we choose operation is 2. 2 means pop, means delete element. So here display output is popped element is 63, because 63 is we enter in last. So 63 is deleted. Then choose operation is 4. Then here exit the program. I hope all of you understand what is stack and what is operations of stack, how to perform operations using stack, and execute program and keep practicing. Thank you.